Okay, so there's another way to look at a plane. Let's start with this familiar scalar equation. And what I'll do is solve for one of the variables. It could be x, y, or z. It's not going to turn out to matter, but just so I don't have fractions, I'll solve for x. And what do I get? I get 16 minus 2y plus z. Solving for z would be an equally good candidate. And then I'll say, well, look, if this vector p, x, y, z is, if it's on the plane, what does that mean? It means that p is x, y, z. We'll put a big if out here. If p is on the plane, then I can replace x with this expression here. And I'll leave y and z alone. So what do I get? If I just throw that away, I get 16, 0, 0 plus y times minus 2, 1, 0 plus z, 1, 0, 1. Okay, so what do we have here? Well, this is somewhat familiar, right? You have, maybe I'll just get you to recall like a line. A line would be p is equal to p naught plus t times d. So here I have a point that I know is on the line, and then in a single direction vector. Now I have, same as before, a point that I know is on the plane, but now I have two direction vectors. So this is like p naught, and this is like direction vector number 1, and this is direction vector number 2. Now, you shouldn't be surprised that we have two direction vectors, because a line is in some sense one-dimensional, and a plane is in some sense two-dimensional. So the picture here would be something like maybe the plane is down here. And if you put the origin very conveniently up here, funny looking zero vector, there we go. Then your p naught is just some, we'll say, why don't we do a copy of the line, the plane's equation here. P naught plus y d1 plus z d2. So we can zoom in here. Okay. So the picture. So this is p naught. There's a point here. Now d1 and d2 are vectors that are parallel to the plane. So let's draw them at the origin just to say, okay, well this guy, let's say this guy is d1. And we'll have d2 going horizontal just to drive home the point. Now to make sense of this equation up here, you can just say, well, if I choose a a point P at random here on the plane. How can I get there? Well, I can get there from the origin by first adding the vector P naught. And then doing some multiple of D1. So this would maybe be like, what's the vector? So this is like some multiple of D1 right here. And then we can do some multiple of D2 to get over to P. Okay, so any vector P on the plane is from the origin. First of all, P naught plus some multiple of D1 brings me here, plus some multiple of D2 brings me here. And this is true for any point P on the plane.